Couple definitions that we need. The first one. All of these graphs of sines and cosines have something called the midline. The midline is a horizontal line halfway between the highest and the lowest points. The midline is a horizontal line. Oh my goodness. That is now an H. It is a horizontal line halfway between the highest and the lowest points. We should be copying down this definition. A midline for these graphs, so hold on a moment. Let's just write it down and then we'll actually think. Horizontal line halfway between the highest and the lowest points. And every sine and cosine graph will have a midline. And this is important because our next few definitions will be based on this midline thing. So we're going to need to make use of this. It's a horizontal line halfway between the highest and the lowest points. So flip back. Philip, what did you want to say? No, not yet. Hold on. Okay, so I'm looking at my graph of y equals the sine of x, and I'm going to draw in my midline only because it will help with a few things moving forward. What height would that midline be at? Think for a moment and raise your hand if you think you have an idea of what the height of the midline might be. Raise your hand. Katie.
Raise your zeros.
0. Because my lowest y value was -1. My highest was +1. What's halfway in between those? 0. So in this case, it's right on the x-axis. What about for the cosine, though? Still the same thing. The midline for my cosine graph is still going to be the x-axis. Now, no, it won't always be there because soon we'll talk about moving these things up and down, and well, that will just change our midline a little bit. That's really not going to be a hard thing, though. Next definition. The amplitude. Yeah, not totally. Yes. The amplitude is going to be the vertical distance from the midline to the highest or to the lowest points. The amplitude is the vertical distance from the midline to the highest or the lowest points. The amplitude is the vertical distance from the midline to the highest or to the lowest points on our graph.
Is it always going to be the same for the highest and lowest points? Like, is there any different distances between the midline and the highest?
Okay, so hold on 1 second. Can I flip back to the previous page? Okay. So, the whole point of the midline is the midline has to be halfway between the highest and the lowest, so it has to be that same distance.
So it's plus or minus 1.
It's distance. Distance is only going to be positive. So what are we going to say?
1.
The amplitude here is 1. You're going up 1 to get to the highest. You're going down 1 to get to the lowest. Amplitude is always a positive number. It is a distance, so the amplitude is 1. What about for your cosine graph?
1.
Still 1. We'll talk about changing the amplitude in a little bit. Outside of, like, this class, have you heard the word amplitude anywhere else? Light waves, absolutely. Well, light waves form like one of these sines or cosines. Have you heard that word related to, like, sound at all?
No, amp.
What is that? What does an amp do? It makes it louder. The amplitude, so someone mentioned that these kind of look like sound waves. Maybe that was A block the other day, I don't remember. But sound waves kind of look like sines and cosines. The amplitude will actually tell us how loud the sound wave is. So if we have a bigger amplitude, it will be something that's louder. More with this in a little bit. Next, the period. So this is a little different. The period. All of these, no, I need you listening. All of these sines and cosines have what we call the period. The period is the shortest, please listen, the shortest horizontal distance before the graph repeats its pattern. The period is the shortest horizontal distance before the graph repeats its pattern. You're going to need more than Kleenex to wipe that up. Please go get paper towels from the bathroom, and there's Windex over there. The period is the shortest horizontal distance, we'll figure out what this means in a moment, before the graph repeats its pattern. Wavelength, that's a little bit different. It's related to frequency. A few of you still writing. Yeah, hold on. That looks a lot scarier than it actually is. Turn back to the previous page. Jack, are you still writing? Okay. Then I'm going to go back to the previous page. I want to figure out how far I need to go before my graph starts to repeat its pattern. I'm going to start at the origin just because that's a nice, easy starting place. I'm going to start over here. I'm going to go up. That's not a great color. Because these aren't straight lines, these are curved things. Okay, I'm going over here. As I continue, is my pattern repeating or is my pattern still continuing? Okay, I've gone up. Now I'm going down. Okay. If I continue, am I like starting the pattern over or is it still continuing my pattern? Okay, so I'm going to keep going. Okay. If I continue, is it going to start the pattern over or just keep going with? Okay, this is not so interesting so far. After 2 pi, is it going to keep going or will it start my pattern over? Here's where it's going to start the pattern over. I just traced out one period of my graph. What was the period? Okay, so hold on. I'm going to say that the period was 2 pi. I started at the origin because that was a nice, easy place to start. There's no reason we have to start there. We can start this anywhere because it does keep repeating the same pattern. Let's say I'm starting over here. So now we're going to have to think a little bit. If I go from here to here, forget this. Why don't I trace out the whole thing? Would you agree that if I traced out the whole thing, I would be stopping over there? Each space is pi over 2 units. Pi over 2, plus pi over 2, plus pi over 2, plus pi over 2. That's 4 pi's over 2. That's still 2 pi. I start at the origin because that was a nice, easy place to count from. Doesn't matter where you start. You're still going to go that same fixed distance before the pattern starts to repeat. The period for a sine graph is 2 pi.
But if you start at the origin,
the origin is just a nice, easy, because then we can use the tick marks. That's
is each box 90 degrees or
pi over 2.
degrees?
Yes.
Okay.
The way it was labeled here, it might be labeled differently in some other problems. Question, Duda.
Is it always going to be 2 pi?
For right now, yes, we're going to change the period in a little bit, and we'll see how changing it will do things.
Wait, so what's the difference between the green and the light blue again?
So the light blue, I traced the thing out, I counted 2 pi. Claire asked, well, do you have to start at the origin? Could you start somewhere else? So I started it over here. If I start over here, I'd finish tracing out a pattern by the time I get there. But it still has a length of 2 pi. Doesn't matter where you start. I start at the origin because that was easy. Jalen.
How come we don't have tangents?
Maybe we'll get into that at the end. The short answer is because when we had those tangent calculations, sometimes we got undefined for an answer, and it does some strange things. We're not going to focus on that here. Maybe at the end I'll show you what it looks like. Okay, what's the period for cosine? It's still going to be 2 pi. period of a cosine graph is still 2 pi. If you trace that thing out, it'll start repeating by the time you get to 2 pi. And again, you don't have to start at the origin, you can start anywhere. Now, I feel like 2 pi actually makes a whole lot of sense. Have you heard that number anywhere else? Okay, the whole point is sine and cosine values start to repeat once you make your way around the circle and then start going through those angles again. Well, one whole time around the circle is 2 pi. So this is really like saying you go 2 pi units around the thing, then it's going to start repeating those values because of how the unit circle works. That's why this thing is 2 pi. Next, well, no, because we need to know what those angles are. One more definition. This is a really easy definition, although it looks like a strange word. A sinusoidal function.
Oh, yeah, that.
This is a fancy way of saying a function that includes a sine or a cosine. We're going to be graphing some sines and some cosines. I don't want to say graph the sine or cosine. This is my way of just kind of grouping them all into one thing. A sinusoidal function is a function that includes a sine or a cosine. A sinusoidal function is a function that includes a sine or a cosine. We are going to start doing some transformations. While you're doing this, I'm going to pass out the final 2 strips for our library of functions. What I would like you to do right now, A, B, C, D, I would like you to decide what is the parent function. Is it a sine or is it a cosine? And then sketch that on there. Don't deal with the number out front yet. I want to deal with that together. So I'm giving you the sine right now. The cosine is coming out in a moment. Oh my goodness. Okay, I'll call the office. And they'll come up with a mop. Right, and it's going to be sticky because they didn't thing with like cleaning supplies.
Call Alex Canero.
Okay, right now, you are going to get some parent functions.
Jalen, put the caps on your phone.
Oh my goodness, thank you, Claire. Please do that right now. Jalen, please. Oh my gosh. Please graph the parent function for A, B, C, and D. I need to go take care of something. Please get those parent functions on there. Hello? Hi. Would it be possible to get Alex to come up to my room with a mop? Thank you. I will let Jalen explain why. Okay, you guys need to get those sines and cosines graphed on there. We gotta move. And after you finish this, take out your colored pencils because we'll need those in just a moment for our transformations.
Wait, it's way less. It's way more like.
A, B, C, and D. Just the parent functions. Ignore the numbers out front. We'll take care of those together in a moment. And ignore the box that talks about amplitude. We'll figure that out later. Not yet. There may be some stuff at the end of the unit, but not right now, because these are things we will need to be able to graph by hand. And again, when you're done, please go on to the next page as well. Take care of C and D. Let's get the parent functions for those. If it was me, I'd probably just keep those 2 strips out for all of today so you can have those parent functions in front of you. No, you need to know what they are by the time we get there.
I have like 10. You help to bring them up,
Sometimes these things take a little while.
but if he comes up, he doesn't know what he's in for.
I asked him to come with a mop. Okay, we really kind of need to get moving because this is actually the easy part of today, and I need to make sure we don't have to rush through the hard parts.
That was sticking out.
Okay. Go back to letter A. Back to letter A. Even if you're not done getting the parent functions in there. You know what? You already know this. If we want to graph y equals 2 sine x, raise your hand if you think you can tell me what that 2 will do to this. Do it up. By 2. Sure. So this point over here has a y value of 0. It's now 0 times 2, 0. This point has a y value of 1. 1 times 2, 2. This is nothing different than what we've done the rest of the year. 0 over there. Negative 1 becomes negative 2. And so on. So that's what we're going to figure out. Yes, again. Is that any better? I can also move you to Nathan's seat if you want for today. Have we changed the period? I don't think so. I think we're still going 2 pi units before it starts repeating. What did I change? What's the amplitude? 2. Okay. There's going to be a shortcut way to find the amplitude that we'll see in a moment that you probably already see. I'd like you to do letter B. I'd like you to do letter B. And actually, you know what? When you're done, I think you could figure out C and D as well on your own. I think you can. I have confidence in you. I think I do. Try C and D with the negatives. After these first few, we're going to see a shortcut that will really let us just skip to the final graph. We won't actually need to start by showing all the details of the parent function. But hopefully your B looks like that. What's the amplitude? 4. I bet some of you are already seeing the shortcut for finding the amplitude. It's not a hard shortcut. What? Let's just keep working. in letter C, what's that negative out front doing to it? Flipping it. Okay. Is that different enough? Not really. So I'm going to I could flip it, or if I wanted to think about it this way, I could also multiply the y values by -1. Either way will still get you to the same place. Make sure, if we do have multiple graphs on one grid, we're color coding things, telling me what's what. Have you finished C?
Yeah.
What's your amplitude?
-1.
1. It's always a distance. It's 1. A was 2, B was 4. Oh my goodness. We're going to try to not be distracted by this. And have we finally closed?
It's all done.
I'm so sorry. Go talk to Jalen over there. The one with the now empty bottle. Yeah. It was orange. Jalen, maybe move some of the stuff away from under your desk. And actually, maybe for right now, move to over there. Thank you very much. Okay, we should be doing letter D. We should be doing letter D. Yes, I know. I know. Do letter D. Do letter D. Shreya. Right, because amplitude is always a distance. Is D going to be stretched more? Less. And it's going to be flipped. So, if anyone is still listening, let's see. I think your graph should look something like this in letter D. Thank you very much. Byron, what's the amplitude in D? 1/2. Okay. There's a shortcut way for us to find the amplitude. Go back to the previous page. It will never be negative. If we have something in the form y equals a times the sine of bx or y equals a times the cosine of bx. Preston, what do you want to say?
The amplitude is the absolute value of A.
Why did you not just say the a value? You're right.
It can't be negative.
Yeah, the number out front, make it positive. How do you make it positive? It's just the absolute value of the number out front. If you look in letter A, amplitude is 2. In B, the amplitude is 4. C, the amplitude was absolute value of -1, 1/2. It's always a distance. Amplitude is always positive. The negative just means we flipped the thing. Now, the period is a little bit more involved. And I think I need to shut this off for a moment and show you something on here. So I'm going